the VDEV.
I like it.
Okay, so welcome everyone. We're very glad to have Debraj today talking about measuring upward mobility. As you'll see, one of the organized garants is also a co-author in this paper, so she will be on the Q&A. Since most of you are frequent participants, frequent flyers on this, I guess we don't need to repeat what the structure is, but in the first 45 minutes, we'll let Debraj talk continuously uninterrupted. But then in the last 15 minutes, we open up the mic and we'll let you know when that happens so you can ask your questions directly. Without further ado, I guess we can go ahead, Debraj, and listen to wonderful measurements. Thank you so much.
Good. Let me share the screen here. Hang on. View screen. Can you guys see this? Is
Perfect.
this okay? Hi guys. Hi everybody. Sorry, this is a conceptual paper as opposed to a data-driven paper, and I hope you will indulge me with this, joint with one of your eminent co-organizers, Garance Genikov, who's also a very good friend of mine. And usually I love people asking questions during my talk, but here I'm slightly relieved that I have 45 minutes because it's a long argument which I would like to develop, and hopefully by the end of the development, some of your questions will have been answered. But hopefully not all of your questions will have been answered. So let's see. Okay, so this is a talk on measuring upward mobility, and both these words are important, upward and mobility, and I'll make that clear in the talk. So in general, when we talk about mobility, of course, we talk about the ease of transition between various social categories. Some of them are unranked, like location or political persuasion. Some of them are ranked, like income and wealth. And as you guys all know, the idea of mobility in general is centrally important in current debates, both in the United States and Europe, but also in the context of development, where I hope this talk will be of some interest to you. Now, Garance and I have done some work on aspirations and growth and so forth, and we had a long-running project on mobility, and our first instinct was to take a measure of mobility off the shelf. Well, we looked on the shelf, and the shelf is extremely crowded. Okay, so you have a mix of what one might call, what you have up there on the screen, what are called non-directional measures, just the idea of mobility as movement, moving around on a transition matrix. Then you have a bunch of directional measures where we realize that we are working on categories which are not like mobility between New Delhi and Calcutta, but mobility between lower income and higher income. So then movement up has a higher meaning than movement down. And apart from this particular distinction, there's another kind of orthogonal distinction, which has to do with mobility as relative movement, relative to others, as opposed to absolute movement, which is just the absolute change in one's circumstances. And as you might imagine, when you have at least 4 categories like this, you will have all sorts of combinations, and they give rise to a bewildering variety of measures. So this is not exhaustive, but I just put it up not for you to read it, but just to show you, we can probably write down 20 more of these things, how many measures of mobility are up there. And, I'll put the slides up and you can take a look at these things in more detail. Now, so as soon as we sort of peeked onto that shelf, we realized that, the conceptual, we just didn't know which measure to use. I'm not a big fan, and nor is Garance, of taking a measure off the shelf and just using it. We want to make sure that the conceptual foundations are clear for us, okay? So what we want to do is develop, we wanted to start from scratch, okay, and develop a measure of mobility for both conceptual and practical reasons, okay? So conceptual reason was that for this very large variety of measures, the foundations are unclear. When clear, they're problematic, and I'll make this more transparent later on. The second thing we realized is that typical measures of mobility of course, are very place a lot of demands on the data, right? Because existing measures rely heavily on panel data, and I'm going to come back to this, more discussion later. And of course, as you might imagine, this has held back empirical work, especially on developing countries where panel data is the exception rather than the rule. So in this paper, we're going to talk about a measure of upward mobility that has two properties, okay, two fundamental properties. The first is that it's directional. It's going to reward growth and it's going to punish decline, okay? So you must remember that this is not a measure of pure movement. It is an algebraic measure which is positive in one direction and negative in the other. The second feature of this measure is that it is progressive, okay? And this is the emotional core of the term upward mobility for us. The emotional core is that the measure is progressive in the sense that relatively poor people enjoying faster growth is a positive for upward mobility. So as I said, we're not interested in movement here for the sake of movement. So I've talked to you enough about movement. Let me say something about progressivity, okay? So now, an obvious question that comes to mind is that if you had two trajectories like this, one for A, one for B, and A initially starts poorer, B initially starts richer, are we to favor this entire trajectory of A simply because we are progressive? And the answer is obviously not, because halfway through this process, they've switched ranks and A is now richer than B. So the very concerns, the very positive concerns that we were assigning in favor of A, halfway through the process must now be assigned in favor of B. Okay, so we can't just write down something like if A is poorer to begin with, then all her growth has to be rewarded. Okay, so we're going to come to that issue in a second. So it's because of the possibility of income crossings or crossings of whatever state variable you're interested in, is that we divide our approach into two parts. Okay, so this talk is going to really have two broad parts. The first part is going to be concerned with an object that we will call an upward mobility kernel. Okay, so the idea is that it is a measure of mobility at any instant of time. It is not an empirically suitable measure. It is a measure that I'm going to write down in order to build the measure that I'm interested in. Okay, so this part is conceptual. So I'm going to write down an instantaneous measure of upward mobility, which is both directional and progressive in the sense that I talked about earlier. And then using this kernel, I'm going to extend it to the idea of a mobility measure on trajectories, on entire income trajectories, that would be based on the implied collection of instantaneous kernels that these trajectories generate. Okay, so all of this is going to become more clear in a few minutes. Now, the advantage of using an instantaneous mobility kernel is that the diagram that I drew earlier, what happens if I start favoring A and then A becomes richer than B, that is, conceptually speaking, not going to happen at any one instant of time, right? Because if two people have different incomes, then no matter what the continuous time growth rate of their incomes in one instant of time is not going to cross. So I'm conceptually free of the issue of income crossings. Of course, I have to pay for it somewhere, which will be later on when I talk about trajectories. Okay, so with that in mind, now let's think about the domain of our analysis, yeah? So the central variable is a variable that I'm going to call income, but ideally I want it to be some state variable which adequately captures the well-being, the present value well-being of a dynasty at any point of time, or an individual, whoever you're interested in, right? So ideally, maybe you should call it wealth, or maybe you should call it permanent income or consumption, people like Angus Deaton have argued, but I'm just going to use the word income for this. Okay, so this should be very clear, and we'll come back to this issue later on. So what do we have for each person? So for each person, we have some data. So what's the data? The data is, first, we know their baseline income, okay, which I'm going to denote by YI for person I. And second, we know the instantaneous growth rate of that income, okay, which I'm going to denote by GI. As you see, the definition is down here. It's Y dot I divided by YI. And now imagine that there is a collection of N people. So I'm going to think of my domain on which I apply my mobility measure as the full collection of all conceivable yi, comma, gi's, vectors of them, over all people. Yeah. Now, of course, n here is the population size, and n itself may be variable. So the domain is this gigantic object which consists of all sorts of vectors, and each element in the vector is actually a pair, right, of income and the growth rate of that income. And I want to think of an upward mobility kernel as a function that takes any one of these objects, which I'm calling z, right, and gives you a number. It spits out a number, which is the upward mobility of that situation at that instant. Now, I'm going to make certain assumptions on this, which are completely standard, so I'm not going to talk much about them. But of course, if you're interested later, we can talk in detail. Firstly, that the measure does not care about who's who. It doesn't care about names. It just cares about their characteristics, in this case, income and the growth of income. The measure is continuous, okay, in income and the growth rate of income. If the growth rates are all zero, all of them, every one is growing at zero, then I'm going to normalize the measure to take the value zero. So the measure can be negative as well as positive. Yeah. And finally, there's a consistency axiom that links different populations together and creates consistency across populations. Again, if you're interested, I can come back to these, but these are weak background assumptions. But now comes the substantive and important restriction on this mobility measure, which is what we are going to call growth progressivity. Yeah. So growth progressivity says that if I start with any situation and I take any pair of individuals, and if individual I is poorer than individual j at that particular point of time, so yi is smaller than yj, then if I take a transfer of any epsilon of growth percentage points and transfer them from the richer person to the poorer person, then mobility should go up. Now, for those of you who are kind of interested in theories of inequality measurement, this looks kind of vaguely familiar. It looks a little bit like the famous Dalton transfers principle for inequality measurement, which says that if you transfer money from relatively rich to relatively poor, then inequality goes down, right? But this is talking about the transfer of growth rates. It's a dynamic concept, okay? It does not live on the same domain as the transfers principle, but it has a parallel. Yeah. So let's look at a couple of examples. So let's suppose that you have two people, their incomes are $5,000 and $10,000, okay? And they're growing both at 8% and 8%. Then I would like to say that this situation is more mobile than if they were growing at 6% and 10%, okay? Where the poorer guy was, so this idea of catching up is important in the emotive content of upward mobility. Now, here's another, maybe a more interesting example. I want to say, look at a society where the 5,000 guy is growing at 2% and the 10,000 guy is shrinking at 2%. I want to say that this is more mobile than a society where neither of these guys is growing at all. Okay, that's 5,000 and 10,000. Okay. Now, the first, I want to make two remarks. The first remark is, of course, that there is no crossing in continuous time. So you don't have to worry about, oh my God, what if we transfer the growth rate and now this guy becomes poorer than the other guy, whereas he was richer to start with. All of that is clean because it's happening in continuous time. No crossings are going to occur in an instant. So do not fear. Yeah. The second is, I want to go back to this connection with the Lorenz ordering for inequality measurement. And I want to point out to you here that what we are transferring is growth rates. So that means this particular measure of mobility is willing to entertain a drop in the aggregate growth rate of the economy and yet say that the situation is more mobile, right? Because when I'm transferring a growth percentage point from rich to poor, the aggregate growth rate of the economy is dropping. This should also serve as a warning or as a reminder that mobility is not the same as welfare. Mobility is one component of welfare. You have to combine it with the growth rate, you have to combine it with whatever else you're interested in, with poverty, inequality, blah, 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 in order to arrive at an overall understanding of the situation. But this is just from the viewpoint of mobility itself. Okay, and with that, I will state my first theorem, very easy to state, and I will not talk about the proof, but just to give you an idea, here is the astonishing power of the growth progressivity axiom. The growth progressivity axiom implies, if and only if, that the mobility measure has to be written as a linear sum of growth rates. The mobility must be linear in growth rates. And I emphasize this because this is going to be central to the argument that I'm going to develop later. Now, these growth rates are, of course, weighted, right? They're weighted by a perhaps complicated object, and that object depends on the baseline incomes, baseline income of person I and the baseline income of every other person. Okay? And it does have this property. This is a trivial property, right, from the axiom, which says that if person I is poorer than person J, the weight has to be higher than on person I. That part of it is obvious. But what's not obvious is that the mobility measure has to be linear in everybody's growth rate. You cannot write down a wavy mobility measure and retain the growth progressivity axiom. So I'll come back to that issue later if you guys have questions. Okay, so I just wanted to show you that to show you in sharp context what the growth progressivity axiom implies. But we typically add on other axioms. I'm going to do so now. Most of these are fairly bland. And so let me just write them down for you. The first is income neutrality. Income neutrality says that if I look at a particular situation and I scale up everybody's baseline income, you just scale it up, multiply everybody's income by 2, then mobility is unchanged. I'm not multiplying the growth rates. Notice that the lambda is only multiplying the incomes and not multiplying the growth rates. The second is what I call growth alignment, which says that if everybody's income is growing faster, everyone in the Pareto sense, right, then mobility is higher. Okay. And the third axiom here is called independent pairwise growth trade-offs, which says that the comparison, so let me go a little bit slowly here. I'm picking out 2 persons, I and J, okay? And this is the rest of the society. I'm holding them fixed. On the right-hand side are the same 2 persons, I and J, and this is the rest of the society. I'm holding them fixed. Now observe that I'm holding this object here on the left-hand side and this object here on the right-hand side is identical. The incomes of the 2 persons, YI and YJ here, and YI and YJ there on the right-hand side are identical. The only thing that's different is GI is different from GI prime, and GJ is different from GJ prime. And I ask you, the researcher, do you think that the left-hand side is bigger than the right-hand side or smaller, right? The axiom states that your answer should not be dependent on what's happening to third parties. That's what the axiom states. Okay, so the axiom says nothing about whether this is bigger or that is bigger. It says that your answer should be insensitive. And then it turns out that under these 3 additional axioms, and assuming that there are at least 3 people in the society, mobility has to have the form that I've written down at the bottom of the page. So, of course, it's still linear in growth. That was already there from the previous theorem. But in addition, the weights have to take the form of geometric weighting of income for person I, where the weights are, of course, negative. So alpha is positive, but is raised to the power minus alpha. So the poorer the person, the greater the weight that she receives. Okay, and the denominator of this essentially makes the whole thing add up. You know, the sum of the weights add up to 1. Okay, so that is that is what the mobility kernel is all about. And now I want to move towards a measure, the kind of measure that the empirical researcher would be more interested in, which is the measure on trajectory. So what's a trajectory? A trajectory, let's say 2 units, 2 instants of time, 0 and t, and this orange line just tells you what income is for a particular person between 0 and t. Here's a blue line which tells you what it is for some other person between 0 and t. And now here's another more complicated one where the blue line becomes poorer and then richer and so forth. So what is this bold-faced Y over here? Now what we do is we say that our domain is the collection of all vectors of income trajectories. Okay, so this one is a collection of yi of tau, where each yi of tau is like a string laid out on this diagram. And an upward mobility measure takes these trajectories, which are very high dimensional objects, and spits out a particular number for you. Okay. But now, of course, we have to deal with the question of income crossings and so forth. Okay, so on this measure, I'm going to place two conditions. Okay, and let me describe those conditions for you. So for this analysis, I'm going to presume that these trajectories are continuously differentiable. Okay, now this is not just a technical point, because there may be jumps that come through sudden promotions, inheritances, and so forth. So I'm going to, if I have time, I'll come back to that. It makes no difference to look at the broader case, but it's easier to do it this way. Okay. Now, if the trajectories are continuously differentiable, then notice that they induce at each point of time these little mini instant problems, right? They induce at any point of time a vector of incomes for everybody and an instantaneous growth rate of those incomes for everyone. Yeah. So in short, a trajectory induces instantaneous mobility kernels, like a whole huge number of them, right? A continuum of them over this entire space. There are mobility kernels sitting everywhere. Okay. I will say that my measure is going to be reducible if it's expressible as a function only of all these instantaneous mobility kernels. Okay, so what it's saying is that there's this overall mobility over this whole period of time, and I want to say that this overall mobility is just fully determined by the collection of all the instantaneous mobilities across these points of time. Okay. Now, one useful analog for this is, if you think of welfare economics, okay, this is a completely wild analog, but I'll say it anyway. Think of welfare economics and think of each instant of time as a person, and think of each instantaneous mobility as a person's utility, and think of the overall mobility measure as social welfare. So then what is it saying? It's saying that overall social welfare depends on all the welfare of the individuals, the individual utilities, but it doesn't care how those individuals got those utilities. Okay, so that's what Bergson-Samuelson non-paternalism is all about. It doesn't care how those mobilities came about, but it presumes that this entire collection of mobilities is a sufficient statistic for the overall mobility of the problem. That's what reducibility says. The second condition is what I'm going to call additivity. Additivity says, well, look at this picture, okay? There's mobility, there are two trajectories here. And I divide up the time period into two subintervals, from S to U and from U to T. And the condition says that the mobility over the overall interval should just be the sum of the mobilities in the individual intervals. Okay. So I say that the overall mobility is additive. Okay. Upward mobility is additive if whenever I break up the S to T with a U in between, then the weighted, of course, if U is very close to S, we don't want to give it that much weight, right? Because it's a tiny interval. If U is very close to T, we don't want to give this interval much weight because it's a tiny interval. So you weight it, okay, by the amount of time. So T minus S is the overall time, and mu is the overall mobility from S to T. And it says that it's the weighted average. It should be the weighted average of the mobility in these two subintervals. That's the additivity condition. And the third theorem says that the kernel axioms, which I wrote down before, the reducibility condition and the additivity condition hold if and only if the mobility measure takes this form. Okay. And for the rest of the talk, I'm going to explain what this form is and its implications. Okay, so you don't have to worry about looking at it too hard for now, but essentially 1 over T minus S tells you it's an average, and it's an average of this object between any 2 points of time S and T. Okay, so that's the main result that we are going to later on take to the data. Okay. So in what follows, as I said, we're going to look at different aspects of this measure. Okay, so I've written down the same mobility measure up there again. And let's look at it. What is this object? Can we get a grip on it? Okay. Well, one way to look at it is to write down the following welfare function due to Tony Atkinson. Okay, so remember the Atkinson index, the Atkinson welfare of individuals is the sum of their incomes, but lower incomes are given higher weight. Okay, and then it's like a CES production function. You're generating Atkinson welfare using a CES with lower incomes being given a higher weight. So you put the -1 over alpha to renormalize the CES and you take the average, right? But it turns out that this object, our mobility measure, turns out to be the average growth of Atkinson welfare, or what is called Atkinson equivalent income, right? It's the same thing, Atkinson's equivalent income, between time S and T. Okay, so that is the welfare interpretation of the measure. But notice that it is itself, the mobility measure is not a welfare function. It is a change in the welfare function, where the welfare function comes from Atkinson. Okay, so that's the first comment I want to make. The second comment I want to make is that upward mobility and growth, just standard growth, are sort of formally related. And this would give you another way of seeing it. Okay, so what's growth? Well, growth is you just add up all the incomes at the later date, divided by all the later incomes at the earlier date, right? Take the log of that because we are interested in growth, right? And take the average, 1 over T minus S, right? So that's what growth is, right? So if you, but if you stare at this mathematically, you see that growth is therefore our mobility measure, but with alpha set equal to -1. Okay, that's one way of seeing it. But our upward mobility measure, notice, insists that alpha is positive, right? So, so while growth is formally, looks like a mobility measure, it is not. It's far away. In fact, the growth rate does not even sit on our boundary as alpha goes to 0. Okay, because the growth rate is defined for alpha equal to -1. If you see the mathematical similarity here, and our mobility measure is only defined for alpha positive. Nevertheless, as it turns out that if all the growth rates are the same, our mobility measure will actually obey the growth rate and it'll return the average growth rate to you if everybody's growing at the same rate. Okay. So, so that's upward mobility, that's growth. Now notice that upward mobility, as I've defined it, is an absolute measure because it's both directional and absolute, because it says that when everybody's growth rates increase, upward mobility increases. So you can define a notion of relative mobility by taking the absolute mobility measure and subtracting out the growth rate, and you get another measure which you can use. And this measure is completely renormalized out for the growth treadmill. There's no growth treadmill anymore. Okay, we've taken it out, and you can apply this as well. I'll come back to that. This measure also can be further axiomatized. Okay, and that brings me with, well, we started 2 minutes late, so with about 18 minutes left, to the heart of the paper. Okay, and this is the heart of the paper. So the heart of the paper is that this measure does not require panel data to implement. Okay. Now, first, let me state what I exactly mean by that, and then we'll have a discussion about it. So that means, for example, when you're adding up at time t, right, the j that you're using to add up has nothing to do with the j that you're using to add up at time s. They could be different j's. Okay. So this is the core of this result. Now, we put in some axioms: growth progressivity, additivity, reducibility. Where did the panel dependence go? Okay, so I want to discuss that. Yeah. So here are possible reactions that you can have. And this is why I said that, this may be just a good way of just letting me go until for 45 minutes. So first reaction is, come on, guys. How can I do mobility from repeated cross sections? Makes no sense. Okay. Well, my answer is let's talk about it calmly. Okay. Let's study how the axioms work first. Okay. So the first thing, remember, I said, is that growth progressivity implies linearity of the mobility kernel and growth rates. Okay. Remember that and keep it in mind. The second thing we did was we took reducibility. We said reducibility means that we can write down overall mobility as a function of all the mobility kernels. So I've written down the mobility kernels here explicitly for you, linear in the growth rate. So what I do is I open out the formula for growth rate, which is y dot divided by y, okay? And then I use additivity to say that if the measure is additive, then it has an integral representation. So it's goes from this phi to actually being able to integrate this object over time. Now, once you integrate this object over time, the fact that it's linear in growth rates allows you to integrate the incomes out completely in between, and it'll integrate out to Atkinson welfare. Okay. Now that's a mathematical restatement of what I said, but it's still a conceptually important restatement, because if you're worried about panel independence, you have to look at one of these axioms and say, I don't buy it. Okay. Because the rest of it follows logically. Yeah? So that's the first point I want to make. Reaction 2 is just like, come on, don't give me algebra. Mobility is a dynamic construction for dynasties or lineages. So how did you take the panel out? Yeah. So let's think about that. So in part, let me agree with you. So to assess the fortunes of a family over time, that family has to be tracked, no question. Okay. But when we're measuring upward mobility overall, we're not interested in tracking a family. We're interested in tracking society. It is society that has to be tracked. Okay. And what does that mean? It means that a particular family receives different weights in the mobility measure depending on that family's relative location at the time. Okay. And the impact on overall mobility feeds through this impact on mobility kernels at the time, right? And when that family becomes richer, with the same sense of blind justice with which we trusted the poorer family before, we favored the poorer family before. Now, when the families switch, we favor the new poorer family. Okay, so these nimble, what I call nimble weight switches, these are central to the argument. Okay? But we could still say, but what about mobility as pure movement back and forth? Okay, and my answer to that is, well, if you're really interested in mobility as pure movement, for example, between New Delhi and Calcutta, let's say seasonal migration, do not use this measure. Okay, this is not the right measure to use. But in our exercise, the categories are ranked, and we don't care about mobility or movement for its own sake. This is something that I said before, right? We care only about upward mobility. So for upward mobility, we have to trade off upward against downward movement. Under pure movement, you can remove the signs, whether they're positive or negative. Both of them contribute to movement, right? Whether it's upward or downward. But under upward mobility, it is the net directional movement that matters, okay? And I'm going to make this like as 100% clear as I can make it, right? So here are two trajectories, which at first sight looks the same, okay? There's an orange one crossing, and then there's a blue one crossing. And notice I'm favoring the orange guy, right? As long as the orange guy is poorer than the blue guy, right? And then when he crosses, I favor the blue guy because he's now poorer than the orange guy. This picture generates the same mobility as this picture, where the blue guy comes down, bounces off, and then goes back up again. Let me make that even starker. Okay, here's a starker example where you have a picture where the orange guy is bouncing up and down, right? And the blue guy is bouncing up and down. And you compare this with the case where neither of them moves at all. For these two things, of course, mobility is different, but upward mobility is not different, okay? They have different exchange mobility or pure movement. They certainly have different inequalities, right? Because on the whole here, the blue and the yellow guy, the orange guy are getting similar similar incomes, right? Over the long haul. So they are equal, more equal than here, and here they are unequal. But it's not inequality we are calculating. It's not pure movement we are calculating. What we are calculating is upward mobility, right? And upward mobility in both of these panels is 0. Okay, now I'm sure there will be more in the Q&A, but let me move on from here. Now, there could be another reaction, which is to say, look, but you need to track these incomes over time because it isn't a sufficient statistic for dynastic welfare. Our answer is that's entirely possible, but imperfection of measurement is not an excuse for changing the measure, okay? It's a reason to use the best data that we have. So, for example, as Angus Deaton and Zaidi have pointed out, try consumption as a good proxy for permanent income, or try wealth as a proxy for a good state variable. So it's not it's not a reason for changing the measure itself. By the way, I would make a similar recommendation to the measurement of poverty or inequality. Reaction 5 is that, okay, even if you solve this problem and individuals do belong to, and we do get a good state variable, it may be that individuals belong to different social groups. Shouldn't we take that into account? Let's say, for example, we are looking at mobility with Hindus and Muslims, right? Should we take the fact that they belong to different social groups who have different maybe per capita incomes? Should we take that into account? And the answer is this is a good question. And this actually requires a separate analysis. This does go into the measure. But in the interest of time, I'm going to ignore it. Okay, so what this particular slide does is that it adapts our axioms to allow for the existence of different social groupings. And it comes out with a horrible looking measure. Okay, but let me tell you one thing about the measure and I'll let it go. That this measure is still panel independent at the individual level, but it becomes panel dependent at the group level. You do need panel data on groups, on Hindus and Muslims, but you don't need panel data on individuals within those groups. And my only hope there, with hands folded, is that panel data on groups is easier to obtain than panel data on individuals. Okay. And the last reaction, this will typically come not from you guys, but from a US or Eurocentric crowd. Man, come on, we typically have panel data, don't we? And you guys know the answer to that question. Even for the United States, Raj Chetty's paper became famous because he used a unique panel of tax records and used that to estimate mobility in the United States. For ordinary mortals, it's impossible to get hold of this sort of data, right? Though some studies like this do exist for other countries. Okay, so now, I have 8 minutes, so I am going to have to make a decision. So there is a comparison of some other measures of mobility, including the Chetty measure, using our axioms, which I'm going to skip. And I am going to now tell you how we can take this particular measure to the data. And that's where I'm going to end. Okay. So let's think about upward mobility in the data. So as I was talking about the work of Raj, very beautiful work, okay? Where don't worry about this particular notation, but what Raj and his co-authors do is that they look at the percentage of kids who are better off than their parents, yeah, for US birth cohorts between 1940 and 1984. And they estimate a transition probability, right, from a unique panel of tax records that they have access to. Now, it turns out, interestingly enough, this is an empirical point. This is not a theoretical point. It turns out that the dependence on exact copulas, the exact transition probability seems kind of limited empirically. Yeah. So there's a very nice paper by Jonathan Berman who says that, if you try to estimate the absolute mobility in the United States, but by just neglecting Raj's copula, right, with different copulas, some of which are very different from the one characterizing the United States, you get a similar evolution of mobility in time. But that's an empirical point. Now, this, of course, we found it irresistible to see what would happen if we ran our measure side by side with Chetty's measure. Okay, so the orange line here is Raj Chetty's measure of absolute mobility in the United States between 1940 and 1985, and the black line is our measure. Okay, and we imitate intergenerational mobility by running 30-year mobility measures. Okay, so we run 30-year mobility measures for a particular value of alpha, but the paper explores different values. And you see that empirically, this is not something that I could have predicted theoretically, but empirically, even though it's conceptually very different, it happens to track the Chetty measure very closely. Yeah. And the paper has more discussion on this. So after that, of course, it was like irresistible, right? We had to see how this mobility measure works in situations where panels are not readily available. So, for example, we tried this. We looked at upward mobility in Brazil, India, and France. So we took data from the world, from the WID, the World Inequality Database, which does not have panels, it has repeated cross-sections. And we calculated both absolute and relative mobility measures using our measure, right? And again, we look at different values of alpha in the paper. So these diagrams are interesting to see, I think, because they do capture a couple of, so the dotted line, let's look at my favorite country, which is India. So let's look at the dotted line. The dotted line is India's rate, India's growth rate, which we know after the 90s really exploded, right? So that's the growth rate. Now, the other two objects are the absolute mobility measure in India and the relative mobility measure in India. Now, one thing that's nice, by the way, about our mobility measure is that you can write them down in the same sort of units as growth, because it talks about the growth in Atkinson welfare. You can just write it down as an annual percentage object, right? So it is very clean to interpret. Okay. And so you see in India, something that we have always suspected, right, that has happened since 1990, but you don't see it, is that there's a dramatic fall in relative mobility. Okay. And so put another way, absolute mobility has certainly gone up in India, but not as much as the growth rate. So you see this. So this is one little thing that I wanted to tell you, and now I have 3 minutes left, and I'm going to use those, or maybe 4 minutes, because we started a minute late. I'm going to use this to say something about a very famous curve called the Great Gatsby curve. Okay, so the Great Gatsby curve asks the following question: how does the initial distribution of income or wealth, whatever, affect subsequent mobility? Okay, we've all been brought up on a steady diet of, increasing returns, decreasing returns. So we know that in convex models like the Solow model, there should be a positive relationship between current inequality and subsequent mobility. Why? Because if this current inequality goes up, then things should revert back towards the mean because of convergence, and therefore it should increase mobility, right? If you have high current inequality. So in a convex technology, like in the Solow model, if I have a spread out distribution now, it's going to point back in towards the steady state. Whereas the classical poverty traps literature, right, non-convexities, missing capital markets, or the psychological traps or aspirations failures, right, of these kinds, they give rise to the possibility of multiple steady states, in which case high inequalities at the beginning could actually give rise to low mobility. Now, there's a very famous speech that Alan Kruger gave in 2012 at the White House, which he sort of dubbed the Great Gatsby curve, saying high inequality is actually correlated with low mobility. And you see this very clearly on this diagram, right? Except that this diagram, of course, has only countries for which good intergenerational data is available, right? And so you can see that from these little two-letter words that these are all developed countries up here. And sure enough, you see a negative relationship, so suggesting that the non-convexities approach may be a better one, between the Gini coefficient in 1985 and intergenerational mobility subsequently. Now, if you hit the same diagram, it's exactly the same diagram with our measure, well, it's not identical, but it works. You also get the Great Gatsby curve. Okay. But then, of course, we can't stop there, right? Because now we are open to apply this measure for all sorts of other countries. Yeah. So we did. We applied it to 86 countries on the cross-section, right? So this is over 1985 to 2015. The left panel of this looks at absolute mobility. The right panel of this looks at relative mobility. Now, if you look very closely here and look at these green triangles over here, these triangles are the Kruger or the Miles-Korak data set on which the Gatsby curve was based, right? It's just a pure cross-section. And you see that, yeah, there's a little bit of a gap, but in the broader scheme of things, there's no Gatsby curve, or at least none that we can see, right? Especially if you look at relative mobility, if anything, there could be, on the cross-section, there appears to be an anti-Gatsby curve. Now, none of this is gospel, right? I'm just putting this up to tell you how we can understand more about the world by looking at this particular measure. And so I'm going to end by, because that was a cross-section, I'm going to end by actually exploiting the panel structure of the data by doing country fixed effects, right? So I'm going to do country fixed effects, time fixed effects for 174 countries in the WID. And we regress absolute upward mobility on initial Gini, okay, over 1980, 1990, 2000, 2010, looking at 10-year mobility data. And man, the coefficients are highly significant, and they go in the opposite direction from the Gatsby curve. I have no skin in this game. I do actually, because I love models of non-convexities or poverty traps. So this is an interesting question that deserves an answer. If you replace the Gini coefficient by the Atkinson measure of income inequality, you get the same positive relationship. And the last table I'll show you is for relative mobility, where again, the positive relationship persists. Okay, so I am going to now summarize. I think I'm 1 minute over, but that's not so bad. There is a bewildering variety of mobility indices. They could be directional, non-directional, absolute, relative. What Garance and I have done is we've axiomatized a class of upward mobility measures. At the core of this measure is the growth progressivity axiom. It's the analog of the Lorentz criterion for inequality measurement, but it's not the same thing. Our trajectory-based measures is then pinned down by two additional conditions, reducibility and additivity. And it turns out to be panel independent. I'm not asking you to buy panel independence, but I'm asking you to think about it very, very carefully and exactly what it means that we are only applying it in the context of upward mobility. And if you're convinced, then this can significantly expand the scope for empirical inquiry. Okay, I'll stop there.
Excellent. So the floor is open. I think Rahid has a question, so I'll open the mic for you. Please ask your question away. Yeah.
Hi, Debraj. Thanks.
Hi.
Super thought-provoking and interesting. It's super interesting. I'm sure you expect to face a lot of resistance in this panel-independent proposed measure, and perhaps it's a terminology thing because you say it's only upward mobility, but what makes it panel dependent is that you subtract, as you were saying, the downward mobility to the upward mobility, whereas the Raj-Shetty measure actually seemed to be an upward because it takes a zero weight on downward mobility and it puts only upward mobility. So perhaps this is just a vocabulary thing. And then looking outside the empirical results that come out of it, would it be possible to think of a decomposition of, if you care about the measure including all kinds of movements, then this would be partly driven by this variation, that the measure that you have, and another one is changes in rank. And it feels like part of what you're saying when you compare your results to the one of Raj-Shetty is the changes in rank would also add to the variation, but it seems not to, the share of changes in rank may not change a lot over time. So at the end, the reason why the two give about the same results should be that more or less there is not that much changes in rank, and most of the change comes from changes in the distribution, because at the end, all you get is the distribution, and you're saying the distribution is enough. If you think that changes in rank don't matter that much for those who care about mobility, because we think it matters if children of poor people are more likely to be rich, that your wealth is not only predicted by where you start from. We think it really matters. So that's what makes it hard to digest. So would a decomposition like this help sort of reconciling the two?
Yeah. Should I answer? That contains a lot of questions, which I think many different people would like to answer. Shall I answer that? And then
go for it. Go for it.
Okay, Rashid, hi, by the way. Nice to see you, man. So here's what I want to say. Firstly, you're absolutely right. We are subtracting downward from upward mobility, as it were. But that in that to get panel independence, that's not enough. To get panel independence, what you need is the linearity of that subtraction, okay? And that linearity is coming from the growth progressivity axiom. So that's the first point I want to make. Just the intuitive idea of, oh, I just remove downward from upward is not going to give you something that's panel independent, okay? But you really require the linearity, and so you have to examine the growth progressivity axiom as well. Now, the second thing you said, which I think is very thought-provoking and very useful, is that imagine writing down upward mobility separately, downward mobility separately, putting a minus sign between them when you're interested in sort of quote-unquote net upward mobility, and putting a plus sign between them when you're interested in just plain movement, right? So you can think of a sort of more general measure where you write down two components. You'll have upward and downward mobility. Part of that measure will have a minus sign in it, which will be capturing directional movement. And part of that measure will have a plus sign on it, which will be capturing total movement. Okay. But what is useful, I think, about our exercise is that it's forcing you, the researcher, to think about the conceptual distinction between these two objects. Okay. And a final comment I want to make on your question about rank. We discussed this at length in our paper. Rank is overhyped. The reason it's overhyped is because think about a poor person and a rich person, and a poor person catching up rapidly with a rich person, but no rank has changed. A rank-based measure will sit back and say, nothing's happened, man, but so much is happening, right? And then the rank-based measure is only going to wake up, right, when the two guys have switched ranks. But not much has happened when they've switched ranks. They've just switched ranks. Maybe their income's changed a little bit. But the bulk of the action has been happening in the cardinal changes, right, of income. And this is what this measure is picking up. Now, let me give you an analog of that. The analog of that is poverty measurement. When we do poverty measurement, what we do is we have an object, which we call the poverty line. And when you fall below it, you're poor. When you're above it, you're non-poor. We know that there are very important paradoxes that come out of using a poverty line. What is it? If you take a moderately poor person and a just poor person, you give money from the moderately poor to the just poor, then poverty comes down, right? But as Sen and Foster, Greer and Thorbecke and others have argued, this is perverse because you're taking a disequalizing transfer from a poorer person to a less poor person, right? And yet the poverty measure goes the other way. Similarly, rank-based measures go the other way for exactly the same reason. Okay. And I think that avoiding rank switches, especially since we have data on incomes, is a very good idea. Okay, I'll stop there.
Excellent. So, Casey, your mic is open.
Hi, yes. Thanks, Debraj. Super interesting talk. And this is a question from someone who's not a theorist and doesn't work in this area. So apologies if it's a bit naive, but I'm just wondering if it's possible to create a version of this measure that penalizes the amount of overall movement associated with a certain set of income trajectories in this case, like conditional on the same amount of upward mobility. Can we prefer things that I guess are more stable for the people who we are imagining transitioning throughout the trajectory? Does that make sense?
Yes, Casey, it does. And except for the word penalizes, for the person interested in mobility, the word would be the opposite, right? Because it should record the amount of movement, right? So except for that word, I understand your question perfectly. And my answer would be the same as the answer I gave to Rashid. Imagine writing down the net measure with a minus sign in between, upward and downward. And if you want an additional component which tracks movement, Casey, if you want to penalize it, we'll put a negative sign. If somebody interested in mobility is interested in mobility per se, we'll put a positive sign. And the other stuff will just take absolute values and track both upward and downward mobility. Okay, but both counting as quote unquote positives, not in the ethical sense, but in the mathematical sense, they would count as positive. Does that make sense, Casey?
Yes, it does. Thank you.
Okay, thanks.
Tamai,
yes.
you might
Hello, Professor. So while we looked at the comparison between absolute and relative mobility for the US, it seemed to be moving together. But for India, there seemed to be a negative correlation between absolute and relative mobility. What could be the reasons for that?
Yes, Tanmay, it's not, the two diagrams are doing different things. In the diagram for the United States, we are looking at absolute mobility using the Chetty measure and using our measure. Okay, we are not comparing absolute and relative in the first diagram that I showed you.
Okay.
It's just showing that our measure tracks the Chetty measure. Okay, in the India case, we are only using our measures. We are not using Chetty measure, our measure, and we are writing two versions of which, one of which is absolute and one of it which is relative. So they're doing two different things, the two diagrams.
Okay, got it. But for like Brazil and France also, they seem to move together.
Not for Brazil, but for France, yes. That's because disequalizing growth, at least this is what the data says, there's been a period of disequalizing growth in Brazil that we all know about. And in India now, it's dramatic with this data, how disequalizing that growth has been, right? Because remember that mobility is not inequality or equality per se. It's, as going back to the Atkinson interpretation, it is the process of becoming equal or the process of becoming unequal that is being captured. Hope that helps.
Yes. Thank you so much, Professor.
Sure, Tanmay.
Karen?
Yeah, thanks. Super thought-provoking. So it strikes me that one other kind of important, it's related to your point on spatial mobility in a certain way. One other important point of the two approaches would be that if you use repeated cross-sections, your population of interest changes over time. Well, if you have the panel, you define at point T, and then you follow, and as a result, with the panel, you know, the very clear thing is at least you know if you lose people, and in particular, if you use them internationally, they show up in the repeated cross-section. So how do you think about that?
Yes. So if you look at, I believe Garant's tell me it's section 6.3 of our paper, I think. So section 6.3 looks at the case of varying populations. So what has happened? So now let's, instead of a trajectory, think of a new thing. There's a bunch of people traveling along, and suddenly, boing, all kinds of new people appear because of population growth, let's say, right? And then they start off. Or maybe some people die, right? And they wink out, right? So what you need to do is, so imagine, I'm trying to draw a picture. So this is 3 people, and then they change into 5 people, right? What you do is you take the lowest common multiple of 3 and 5, which I think is 15, and create an artificial society by cloning these 3 into a society of 15, and cloning these 5 into a society of 15, okay? And use a population principle. When you're cloning, you say that nothing is affected. When you're cloning here, nothing is affected because you're just replicating the society. And then you patch the trajectories up, okay? You patch the trajectories up, you have a constant population society, and it gives you a measure of mobility. And the measure of mobility it gives you is the obvious one, where instead of having the summation of the yi's, you have the summation of the yi's weighted by population shares. So it's exactly what you would want. But that's how we do it in the paper. Yeah.
Excellent. So any other question from the floor? Maybe. Okay, I had actually just one question. I was wondering, and this is actually, exciting because it doesn't need to have a panel dimension to it. But I was wondering whether short panel dimension would do you any good in a way. So how much more can you buy out for short panel dimension?
A lot, I think, because for the following reason. The income data that we have is just not a good sufficient statistic for dynastic welfare. So the more we can average those incomes, right, the more we can get a good measure of permanent income. But our recommendation would be to still average the incomes over the panels and then take that moving average and apply our measure to it. Okay, so the panel is only going to be used to generate better measures of permanent income, but it's not going to change the measure.
Sure. Excellent. So we do have a couple of, no, actually I have a question, maybe. Akiko, do you want to ask your question? You should be able to talk now.
Hi, Akiko. Yeah, we saw her. I don't know.
You're muted, but you should be allowed to. Should be.
Hello,
Yeah.
do you hear me?
Yes.
Thank
Yes.
you very much. So thank you for this talk. And I have a question on the length of a period that you will be considering on the empirically, because it seems to me that you said that as soon as someone is rich and past the threshold, he's rich, so his or her weight would be smaller. But I think that being rich today, but coming from a self-made man from a very low background, it's very different from being rich for many, many generations in type of the type of society. And so
Indeed.
won't you want to try to take this into account?
Yes.
Upward
Yes.
mobility?
Yes, okay. Well, the answer is yes. When you added upward mobility, I was going to say no. Okay. So yes, from the point of view of overall welfare, for sure. Yes, from the point of view of inequality, for sure. But as long as the state variable is adequately capturing dynastic welfare at a point of time, no, from the point of view of upward mobility per se. Okay. Upward mobility per se is, in some sense, it doesn't have a sense of history, provided the state variable is okay. When that poor person was coming up and joining the rich family, the upward mobility measure is going to give you a nice positive number because the poor guy is coming up. At the point where the two meet, the families are treated now in the same way. The measure is not applied at the family level. The measure is being applied at the social level. The measure is not being used to compare between two families. The measure is being used to compare across two societies in terms of mobility. Okay, so everything you say is correct from an intuitive welfare perspective, but from the point of view of just measuring upward mobility, no.
One last remaining question, Francisco. Do you want to go for it? And then that's the very last one.
Hi, Debraj.
Hey.
Hi. I'm thinking that when the intuitive idea we have about mobility is sometimes, when we think in the US, is a situation in which poor countries can become rich and maybe rich countries can become poor. So inequality wouldn't change, from the initial condition to the last situation, because the poor became rich, the rich became poor. And we talk about that as being strong mobility. So I wonder in which sense, your measure is not related to this intuitive idea of mobility, but is a measure of the change in inequality.
Correct.
So in my example, the change in inequality is 0.
Correct.
But there's a lot of mobility.
Correct. So Paco, the way to see it is the following. We are completely agreeing with you that there's a component of mobility. Divide up the mobility to two parts. Let me just say this once more. The pure movement part, which is in the literature typically called exchange mobility, right? Or as Tony Shorrocks would put it, it's just the behavior of the off-diagonal elements of a transition matrix. And the other is what we are calling directional mobility or upward mobility in our case. Now, in the example that you gave, that there was a lot of exchange mobility, but as defined and axiomatized by a measure, there was no overall upward mobility in the world because, as you said, the countries exchange positions. It is true that India became now, in your example, the richest country in the world, but somebody else took India's place and their downward mobility has to be taken into account. Now you might say, why should the two cancel out? And I repeat again, they cancel out because of the derived linearity in growth rates. It doesn't even actually matter that they cross halfway. They can cross 3/4 of the way, but the growth rate changes will take account of all of that.
But let me ask, is there any difference between upward mobility and the change in inequality?
For the relative mobility measure, no. If you use the Atkinson welfare function, if you use the Atkinson measure of inequality, for absolute mobility, yes, of course, inequality can go up and mobility can go up. in the absolute mobility measure, for example, if you have two people and the rich guy grows at 100% and the poor guy grows at 20%, and now you increase both their growth rates, mobility will go up and inequality will also go up.
Okay, I guess this is a good time to stop. We went a bit over, but I think it's super exciting. So thank you so much.
Guys.
Thanks for everything, Debraj. Thanks.
Okay, I'm going to have to
everyone.
rush. Okay, great to see you all.
Bye, everyone.
Bye.
See you
Bye,
in a couple of
everyone.
weeks. I think Xing Yin is going to be in a couple of weeks.
Okay.
Bye,
Bye.
everyone.
Bye.